Dear participants, all are welcome to day 2 workshop on SPSS. We have some technical issues from the resource person, so kindly wait for a few more minutes. Thank you.
Good afternoon, madam.
Yes, sir.
Yesterday I have attended the seminar, but you didn't send the feedback form.
No feedback for day 1 and day 2, sir.
Okay, madam.
Yeah, thank you.
Thank you.
Dear participants, kindly unmute your videos and audios.
Start பண்ணிட்டீங்க.
Dear participants, kindly mute your audios and videos. Thank you, participants. Good afternoon, ma'am. Good afternoon, Shyamala, ma'am. Good afternoon, Shyamala, ma'am. Dear participants, our resource person have reached Kindly mute your audios and videos so that we will not get any disturbance during the session. Thank you, participants. Good afternoon, Shyamala ma'am. Shall we start?
ಇದು ವಿಡಿಯೋ ಆನ್
Good afternoon, Shyamala ma'am. Shall we start the session?
Ma'am, am I audible now?
Yes, ma'am. You are audible. Shall we start the session, ma'am?
Good afternoon, ma'am. Am I audible?
Yes, good afternoon. Yeah, you are audible, ma'am. You are audible. You are audible, ma'am. Good afternoon, ma'am.
Good afternoon, ma'am.
Good afternoon, Shyamala ma'am. Shall we start the session? Okay. Confirm. Work hard in silence. Let success make the noise. With this note, a pleasant afternoon to everyone. It's my privilege to extend a warm welcome to all. On behalf of Faculty of Education, Dr. MGR Education and Research Institute, we welcome you, our research person, Dr. A. Shyamla Devi, Assistant Professor, Faculty of Education, University of Madras, for the second day workshop on SPSS. I also welcome all the principals, professors, and students, research scholars from various colleges. Now the session is yours, ma'am. Please. Dear participants, kindly wait for a few more minutes. Our resource person is having some technical glitch. Kindly wait for a few more minutes.
डाल दिए Ma'am, am I audible now? Excuse me, ma'am.
Yes, ma'am.
Yes, yes.
Yes, ma'am. You're audible.
Okay, thank you. Okay, so sorry for the inconvenience. So in today's session, as I mentioned already, so first of all, good afternoon all. So in today's session, we will be discussing on the basics, how to, what are the components and what are the properties of SPSS package and how to feed the data in SPSS, as well as how to, in case if we are not convenient in feeding the data, in entering the data in SPSS, we can enter the data in Excel. Later on, we can import that in SPSS. So those things, as well as today we will discuss on the descriptive statistics and inferential statistics. We'll discuss on the t-test and different types of t-test and how to do the analysis in SPSS. Okay. So with that, let's share my screen. Ma'am, kindly allow me to share my screen, ma'am.
Yes, ma'am. You can do it now.
Yes, yes, ma'am. I hope my screen is visible now. No, it's not visible.
It's not visible, ma'am.
Okay, okay, let me check. So today I'm using a different laptop because in that laptop I don't have SPSS software. So I don't know. Ma'am, is it visible now?
Visible, ma'am. Visible. Yes, ma'am. It's visible.
Very sorry. Okay. So introduction to statistical package for social sciences, that is SPSS. So let me explain the basic things with the help of PPT, and later on I will try to show the demo in SPSS. Okay. So the topics to be discussed in this PPT is first, what is SPSS and how to create a data file in SPSS and how to import the file from Excel to SPSS. And later on, we'll move to descriptive statistics and how to export the output from SPSS to Excel or MS Word. Okay. So first, coming to this, so we all know SPSS is a, yes, ma'am.
Ma'am, PPT slideshow, ma'am. Yes, ma'am. It is in slideshow mode, ma'am.
For me, it is in slideshow only. Oh.
The PPT,
Is it,
yes, ma'am. Yes, ma'am.
Is it now visible, ma'am?
Okay.
Yes.
Yeah, now okay.
Okay.
Yeah, thank you.
Okay. So originally it is an acronym of statistical package for the social sciences, but now it stands for statistical product and service solutions. Okay, now the acronym has changed. And one of the most popular statistical packages which can perform highly complex data manipulation and analysis with simple instructions. Though we have many softwares for data analysis, still we are very convenient in doing the analysis with the help of this SPSS package because it is very user friendly when compared to other packages. And the latest version of SPSS is IBM SPSS Statistics 24. Okay. And these are the different softwares. May I know my slides are moving? I changed my slide now.
Yes, ma'am.
Okay, thank you. So these are the top statistical analysis software products. So we have many softwares like SPSS. Many softwares are available in the market, but still always we go for SPSS because it's very user friendly, as I mentioned. Okay, now how to create the data file in SPSS? So the first one, as we have to go to start all programs.
Excuse me, ma'am.
Yes,
The
yes.
PPT slide is not moving. It's an introduction. What is SPSS?
Is it so?
Yes, ma'am.
Yes, ma'am.
That is why I asked the host that whether it is moving or not. Okay, let it be not in slideshow mode. Now, can you able to see how to open SPSS window? I'm showing that slide.
Yes, ma'am.
Okay, so if it is in slideshow mode, I think the slides are not moving.
But can you please zoom that? Zoom
Yeah,
out
yeah,
a little.
yes. I'll do that. Is it okay? Okay, only the PPT is problem for us. When I show the demo in SPSS, it will be okay. It's 6. Let's see. That all programs, since I have SPSS 20, I have to click that. Okay, once we click that, SPSS window will open. So in SPSS, we have two windows. Okay, so one is data view and another one is variable view. So the out, and also once you do the analysis, the output will be generated in a separate window. So on the whole, we have three windows. So input window, we have two windows. One is data view and another one is variable view. And the output will be generated in the third window. So we have three windows. And then, so this is the data view. Okay. So I told no, in SPSS, the input window has two view. So this is the data view. And the next one, this is the variable view. So this is how it's look. So we have two windows. And in the variable view, first we have to feed the data. We have to give some basic information in the variable view. And later on, we have to feed the data in data view. So what we will be doing first, the basic information. What are the demographic variables we have? Gender, medium of instruction, type of the management. So these kind of information we have to first feed, enter in the view. Once the basic informations are entered, then we have to move to the data view. There we have to enter the values. As such, we enter in the Excel sheet. Okay. So next one. So this is okay. So the first one. So in the variable view, the first one is name. Okay, let me. So now I'm just opening my SPSS package. Is it visible? Instead of PPT, let me show the explanation. Let me give the explanation from the SPSS package itself.
Not
Is it visible or not?
No, ma'am.
It's not visible yet.
Blank.
Okay.
Maybe if you share your screen.
Yeah, I'm sharing only, but the slides are not moving. I don't know why. But for me, it's moving. I'm changing the slides, but for the participants, it's not showing, it seems.
When you actually start sharing, there will be two options, right? One is for Windows, the other one screen. If you share the screen, I think whatever you do in your desktop, we will all be able to see that, ma'am.
Now is it visible?
Now we are seeing the PowerPoint, ma'am.
Okay, let it be. At least
Only the slide.
Okay. Yeah. Okay, let it be. So now I'm changing the slide. So let me know whether it's changing or not. Is it changing?
No.
No.
We are actually seeing your PowerPoint slides, ma'am, but not the slideshow.
It's not in slideshow mode?
No, ma'am.
No, ma'am. No.
Oh, okay.
Please press Control or F5. Just press F5. You can go in your slideshow.
Yeah. I think. Okay, now I change the setting. Please tell me, is it visible or not? Is it visible now?
No, ma'am. Loading, ma'am. Loading. It is
Can you able to
visible,
see my
ma'am.
desktop?
Kindly. Yeah,
Yeah.
Yes, ma'am. Now we are seeing your desktop, ma'am. Yes, ma'am.
Okay, okay. Thank you so much. Thank you. Thank God. Okay. So now I'm just opening the SPSS. Yeah. Okay. So I don't know, we have two windows in SPSS. One is the data view. So the data view will look like an Excel sheet. So this is where we have to enter the values. And the next one is variable view. So here we have to give the basic information. Only then we can enter the data in the data view. So first one is name. So here we have to enter the name. Name in the sense the demographic variables like gender, what else, medium of instruction. So those information we have to feed under name. So for example, first demographic variable is gender. So I entered gender here. And next, after entering gender, I'm just clicking the enter button. So automatically by default, all other things were filled. It is default. Okay. So the next one is type. Type is whether the data I'm going to enter in numeric or string. So we are going to enter the data in numeric only. Numeric means male means I'm going to give 1. Female means I'm going to enter 2. So I'm going to enter the data in terms of numbers. So it is numeric. In case, suppose if I'm going to enter the data as male, female as female, in that case, I have to click string. Okay. I have to check with string if I enter the data in terms of qualitative, descriptive data like male, female, marital status. But here I'm not going to enter like that. I'm going to assign 1 for male and 2 for female. So let it be in numeric. So here next one is width. So width is nothing but the width, the digits. Okay. So let the width also, let it be 8. And next one is decimals. So whether I want to round the decimal places to 2, so I want 0 decimal places. I don't want decimal places. I will explain once I enter the data. I will explain how it look like when I enter 2 and how it looks like when it is 0. And next here I can enter the label here. See, actually, we can't enter many data in the name column. So under name, we can enter gender, but still many things we can't type under the name column because special characters are not allowed. We should not give space and so many restrictions are there. Can you able to see my PPT now?
Yes, ma'am.
Yes, thank you. Okay. So because those things I have been given in the PPTs, I just want to find it out. Okay. So now just see the, so the first character of the variable name must be in an alphabet. So first character G, gender, G only you have to enter. And here only 64 characters are allowed and space is not allowed here. For example, medium of instruction means you have to type continuously without leaving any space. So under name. And next one is width. So numeric I already explained. So numeric or string, we will be selecting only numeric. And with this 8, always we will be giving 8. Only 8 digits will be allowed. And decimal places, let it be 0 decimal places. And then label. So under label, we can elaborately, we can type the things. 256 characters are allowed under label column. And next we will be assigning the values. under gender, 1 means male, 2 means female. We have to enter the values, assigned values under the column value. And missing values, suppose if you have any, suppose the students have not given their responses against gender. In that case, instead of giving some other gender, male or female, we ourselves, we would have given some male or female. Instead of that, we can give 999 or 000. It will represent the missing value. And then columns. So how many columns? 8 columns. Okay. So now the rest of the day. Okay. So now gender, I'm going to label here as gender. And I'm going to assign values as I have given 1 for male, add, and 2 for female, add. In case I have entered wrongly and I want to change, so in that case, if I want to change male, click that male, and again we can enter the values. Okay. So this is how we have to assign the values here. And missing, we don't have any missing values. And columns, so this is the column width. For example, I'm just reducing the column width here. See, I'm reducing the column width to 1. Now, if I check this in the data view, see the gender column, the column width has been reduced. Can you able to see that? Yes?
Yes, ma'am.
Yes, thank you. So, usually we keep the column width as 8. Okay, and this is alignment, whether you want to align the data in the right side or left side or center alignment. So let it be right side. And then measure. So measure means in the last class, we discussed about the scales of measurement, nominal scale, ordinal scale, interval scale, and ratio scale. And yesterday itself, I told you in SPSS, we have only nominal scale, nominal scale, ordinal scale, and interval scale, ratio scale clubbed together as scale here. See, let me check this here. So nominal, ordinal, scale. Scale means interval and ratio scale together. It is clubbed and shown as scale. And this is input. It is not output. We are feeding the data. So the role is input here. Similarly, see, I'm giving space for medium of instruction. Medium of instruction. Variable contains, name contains illegal characters. So which means the space is not allowed here. So what we can do, we can give a short form, MOI, medium of instruction. And if you click the enter button, the rest of the things will come default. And then decimal places, I just want to reduce the decimal places to 0. And here I can give the detailed explanation of what GOI is. So, sorry, MOI, medium of instruction. Medium of instruction. And now here I'm going to assign the values. 1 as English medium, add, and 2 as Tamil medium, add. Okay. And then no missing values. The rest of the things remain as such. And here scale, we have to give as nominal scale. Okay, so this is how we have to, for example, if I'm going to give educational qualification, let it be educational. So educational qualification, I'm just giving EQ. Okay, and I'm, okay. Education qualification. Name contains reserved. Okay. So here, 0. Here I'm assigning the values. One, illiterate, add. 2, 10, add. 3, 12, add. 3, UG, add. And 4, 10th, 12th, UG, and the 5th one is PG and above. Add. Okay. So now tell me what I have to give under in measure for this. For educational qualification, what I have to check, nominal, ordinal, or scale?
Ordinal.
Yes, ordinal, because here we have arranged the sub in an order, like illiterate, 10th, 12th. So it is an ordinal scale. But for medium of instruction, it is not the case. Even I can assign 1 for Tamil and 2 for English. I can change the order for medium of instruction. But for educational qualification, I can't change the order. So it has orders, hence it is an ordinal scale. Okay. And the next one is academic achievement.
Ma'am, sorry to interrupt. In
Yeah.
the same way, shouldn't gender also be given nominal measurement, ma'am? Nominal. Here it's given as scale.
Yes. Oh, sorry. It is nominal. Thank you. Okay. So next one is
Ma'am, once
academic.
again, ma'am. Ma'am,
Yes.
in values, I think for 3 and 4, we have entered UG. Can you check that once again, ma'am? I think there's a mistake.
Yeah,
Yes,
yeah,
ma'am.
yeah.
Yes.
Yeah. So which means we can change here. Okay. So PG, okay. So let's remove this. Here I have to PG and above. And somebody's talking between. Okay. Is it okay now? So due to tension, I'm typing wrongly. It seems okay. So now the fourth one, I'm at academic achievement. Okay. So for academic achievement, oh, I have given space. Okay. Let it be AA. Okay. So once I enter, the rest of the things will come as default. And here I can give elaborately academic achievement. And should I assign values for academic achievement? Yes. Can I have the
No.
answer? No,
No.
we should. Yes. Only for demographic variables, we have to assign values, but academic achievement is a scale variable, right? It is so here for this, we are not supposed to assign values. So straight away here, what scale I have to give for academic achievement? It is nominal, ordinal, or scale? It is
Scale.
Scale value.
Yes, scale value, because academic achievement is a continuous variable. In the last class, we discussed, no? That is gender, medium of instruction, educational qualifications, or it is a discrete value, but it's a continuous variable. Which one? Academic achievements. Hence, I'm giving scale here. Okay. So this kind of information, once we feed in the variable view, I'm just checking these in data view. See? Gender, medium of instruction, educational qualification, academic achievement. So now as such, how we enter the data in Excel sheet, like that we have to enter here. For example, 1, 1, 1, 1, 1, 1, 1. Okay, so 1 for male and 2 for female. Similarly, for medium of instruction is also 1 for English medium and 2 for Tamil medium. So okay. Educational qualification 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 2, 2. Academic achievement 35, 40. Okay, so now I have entered the data. It's a dummy data. I will do the analysis with the help of some other data. Okay, so we have entered the values for gender, medium of instruction, educational qualification, and academic achievement. Now, academic achievement, see here the decimal places is around 2, it seems. See here for academic achievement, the decimals is 2. So I have to change that to 0. After that, if you check that here, it will be 33, 44, 22, 21, 56. Okay. So, and also in the variable view, we have given right alignment. So for this, I will be giving left alignment. Okay. And for the next one, I will be giving right alignment, the center alignment. And let's check that in the data view. See. So this is not going to affect our analysis part. So this is just for our understanding. Okay. So this is how we have to enter the data in SPSS. But I would have suggest my students that not to enter the data in SPSS, because once you enter the data in Excel, we can easily import that from Excel to SPSS. That will be even more easier for you, because Excel is very user friendly when compared to SPSS. So it's better to enter the data in Excel, and then we can import that in SPSS. So let me show that view. So now I'm having my data here. Okay. Okay. So home environment data. So this is my Excel data. So I'll check with my data. I'll show the data. Okay. So serial number, gender, type of management, medium of instruction, family type, and HE is nothing but home environment. So home environment dimension 1, home environment dimension 2, home environment dimension 3, home environment dimension 4, home environment dimension 5, and this is grand total of home environment. And the last one is academic achievement. So this is how I entered the data in SPSS. Okay. So now I used to ask my students, once you enter the data in Excel, in sheet number 1, in sheet number 2, you have to give the details. That is gender, 1 as male, 2 as female. Because after 5 years or 10 years, if you're going to open the Excel sheet, you must know what is 1 and what is 2. So in next sheet, you just assign the values, what is 1, 2, like that. Okay. Here the type of the management, 1 government, 2 aided, 3 private, medium of instruction, 1 Tamil, 2 English, and type of the family, nuclear family, joint family. So this is my sheet 1. So this is my master table. So now what I'm going to do is, I'm going to import the sheet 1 master table from Excel to SPSS. For that, okay. So now what I'm going to do is go to File, Open, Data. So File, Open, Data. Once you click the data, a dialog box will pop up. So you have to give the where it was located. So it is located in a folder in SPSS class. Okay. So now in SPSS class, the Excel, I couldn't see the Excel sheet because the file type is in SPSS statistics, SAV type. So I have to change the file type from SAV to Excel. So if I change the file type, see now I could able to see the Excel sheet, right? Excel file. So now just select the Excel file and open here. An error, because already I have opened the Excel sheet, so that I should close it. Only then I can open it in the SPSS. Okay, so let me close this here. Okay, let me do it one more time. New data. Open data. Okay, open data. And here I have to change the file name as Excel. So now I can. So it will be asking in which sheet you are having your master table, whether in sheet 1 or sheet 2. So I'm having my master table in sheet 1. So I have selected sheet 1 and I have to give OK. So now easily everything was feeded in the SPSS. Instead of giving 1 by 1 gender and other things, it is very easy. Once you enter everything in Excel and import that from Excel to SPSS, that will even more easy for you. So serial number is not needed. So I'm going to clear that. Okay. So just click it, right click and clear. So now I'm just going to check this under data view. So this is how, so it is, it looks similar like a Excel sheet, right? Gender, type of the management, medium of instruction, family type, then 5 dimensions of home environment, and then we will be having the grand total academic achievement. Everything is over here. Okay. Okay. So So now, the one thing what we have to do is we have to give label and we have to assign values, because we have not assigned values in Excel. That can be done only in SPSS. So that is the only thing we have to do once after importing the Excel sheet from Excel to SPSS. So I have to assign. Please mute yourself. Okay. Gender 1, male, add. 2, female, add. Okay. Similarly, next one is type of the management. Okay, now I'm assigning the values. 1, government. 2, aided. And 3, private. Okay. And next one is medium of instruction. One, Tamil medium. And 2, English. So, okay. And family type, it's already there. I have to assign values. So number 1 is joint family or nuclear family. Did anyone notice that? Okay, let it be joint family. Add. Next one is nuclear. Add. Okay. So now I have assigned demographic variables and the measure, all the measures are nominal only. I have not entered the ordinal scale. So nominal, the rest of the things are scale, because this is home environment dimension 1, 2, 3, 4, 5, the grand total and academic achievement. All others are scale only. So it's correct. Okay. So now we are going to do the analysis part. I hope up to this everything is clear. If you have any doubts, you can clarify now. Any doubts? Or shall I move? Shall I proceed?
Yes, ma'am.
Yes, thank you. Okay, so what I'm going to do, so we are going to do the analysis. Just go and check the analyze here. So let me, first I'm going to explain the descriptive statistics. Okay, so descriptive statistics. Under descriptive statistics, we have frequencies. So frequencies means measures of central tendency and measures of dispersion. If you want to calculate that, then you have to check this. For this, we can't do measures of central tendency and dispersion for demographic variables. For discrete variables, only for continuous variable, we can calculate mean, median, modes, range, quartile deviation, and standard deviation. So don't shift the demographic variables in the variable column. Okay, so we have to shift only the continuous variables. So now I'm going to do the analysis for academic achievement. So you just select the academic achievement and shift that to the variable column and go to statistics. What are the statistics you want to do? We can do that. So mean, median, mode. I want quartile deviation and also standard deviation. If you want skewness value, kurtosis value, or range, whatever the thing you want to do, you can check that and go to continue and next OK. So now the output is generated. So now you can check the output here. So there are missing values. Okay, in total I'm having 400 data. So this is the count. So n is nothing but the number of data, that is 400, and there is no missing value, so 0. The mean value is 76 and median is 75, mode 71, standard deviation is 12, skewness value and standard error obscureness, kurtosis, range, percentiles. So percentile, because I have checked quartile deviation, right? So this is Q1, Q2, Q3. That is first quartile, second quartile, and third quartile. So that is 69, 75, and 85. And this is the cumulative percentage and other things. So this is not, so we want only this table. So now the output is over. See, I already told no output will be generated in a separate window. So this is the output window. So if you want, you can save this output window as said. See, go to file. We can save as. So let it be descriptive statistics. Okay. So don't save as such. Give proper name and then save. So now I save the output. So let me check the output. See here. So the output is saved as descriptive statistics. It's already open. Okay. So once you open this output window, you can view. So in case I don't want to copy, I don't want to save the output as such. I want only the table. So in that case, click the table and right click, copy, and you can copy wherever you want. You can copy that in the Word document, or if you want, you can copy it in the PowerPoint in Excel sheet. So you can copy if you want only the table, just that copy and paste wherever you want. Or otherwise, I just want to export the output. For that, go to file and export. Okay. So where, okay, I just want to, so SPSS class here only. So I just want to save. Okay. Okay. So let me check that output also. So already I'm having output. Okay, this is a different one inside already. Okay. So let me do one more time. So I'm just going to export that. It's already exists. Okay, so this is how we have to export the output from SPSS to the place where you want to save. You can save, or otherwise you can save only the table also. We can save the table. Okay, so descriptive statistics is okay. So under descriptive statistics, first we check with frequencies. So under frequencies, if you go to statistics, what are the statistics you want? That is measures of central tendency as well as dispersion. You can do that. Okay, so that is over. And the next one is going to analyze descriptive statistics, only descriptives. So if I check here, so descriptive means, okay, I mean some standard deviation. So if you're going to this descriptive, we can do same analysis in frequencies itself. So there is no need to check with the descriptives. You can do the same analysis under the frequencies itself. Okay. So next I'm just moving into the compare means. In the last class, I told you that we will be doing the analysis for three things. One is we will be comparing the means. That is t-test and m-test comes under comparing the means. We will be comparing the means of male and female. So when we compare two means, that is t-test. If you're going to compare more than two means, that comes under f-test. So t-test and f-test comes under compare means. Or you can also compare two continuous variables, scale variables. So that is nothing but correlation. So if you're going to find the relationship between two continuous variable, then you have to calculate correlation. And you can also predict, the dependent variable from independent variable. For that, we will be doing regression analysis. So the help of compare means we can calculate t-test and f-test, and under correlation, we can find the relationship between two continuous variable. And in regression analysis, we are going to predict the dependent variable with the help of one or more independent variable. I think this is clear, right? So now we are going to do only t-test. So in this class, I will be covering only t-test because due to lack of time. Okay, z-test, right? So here these are the types of t-test. One sample t-test, independent samples t-test, paired sample t-test, and then one-way ANOVA. So these are the tests, different types of t-test. So what is one sample t-test? So one sample t-test is also known as z-test. Actually, what we are doing here means when the population mean is known, then we can attempt one sample t-test. So comparing the population mean with the sample mean is called one sample t-test. Okay. So only if you know the population mean, you can do this one sample t-test. And next one is independent sample t-test. It is nothing but the t-test actually what we are doing, that is independent sample t-test. And next. So please mute. Okay. And next one is paired sample t-test. So in case if you are doing experimental research, in that case, while comparing the pre-test and post-test scores, we will be doing this paired sample t-test. And next one is one-way ANOVA, which is analysis of variance. Here, if the subgroup is more than two, for example, government aided and private. So if we have more than two subgroup, then we will be doing f-test. It is f-test, or it is also known as one-way ANOVA. Okay. So let me explain even more better with the help of the PPT. Can you able to, is it visible, the PPT? Yes. Okay. So we have three types of t-test. Okay. Yes. First one is one sample test, or it is also known as z-test. And second one is t-test or student t-test or independent sample t-test. All are same. So here I have to, this is different one. Okay. T-test, student test or independent sample t-test. All are same only, but in different names. And paired sample t-test or matched pair test or correlated t-test. All three are same only. So you should not get confused between the terminologies. So one sample t-test is entirely different. Here we are going to use only one sample. For example, in t-test, we will be using two subgroups, male, female, right? But in one sample t-test, we will be using only one sample male. Okay, I'll give you one example for when to do this one sample is z-test. For example, okay, so I came to know that in one government school, the students are undernourished, they are underweight, they are not given proper nutritious food. So what I'm going to do is I just want to check really the students are underweight or whether they are nutritious food or not provided to the children. I want to check that. So what I will do, I know the population mean, that is for 10 years, what will be the weight of 10 years old children? Come on.
35 kg.
Okay, 35 kg. So now this will be the population mean. Okay, so I know the population mean will be 35. That is, the 10 years old children weight will be 35. So this is population mean, which I already know. So what I will do, I will go and check the weight of the students of that particular school, the 10-year-old children. Okay, I will check the weight. I will take average. So with that sample mean, I will check the population mean. So I'm going to compare the sample mean and the population mean. So this sample, one sample t-test can be performed only when the population mean is known. Okay, so now I know the population mean, it is around 35. So now I will check the sample mean and I will compare the population mean with the sample mean. Once I compare, I could able to see whether the students are undernourished or not. So I hope you understand when to perform this one sample test or the Z test. Is it clear?
Yes, ma'am.
Yes. Yes. And next one is T test. Okay. So T test or student T test or independent sample T test, all are same only. Okay. So in T test, what we are doing is we have to compare the two subgroups. So for example, gender is having two subgroup, male, female. Similarly, medium of instruction, Tamil medium, English medium. So for that, we will be performing this T test. And paired sample T test or matched pair T test. Here, why it is called independent sample T test, and here the last type is called paired sample T test. Independent samples means here male and female or boys or girls or Tamil medium or English medium, both the subgroups are independent. They are not dependent, right? They are different groups. So it is called independent. And post test is there will be, but
Ma'am, your voice is breaking.
Okay, is it okay now?
No, ma'am, still breaking.
Breaking.
Yeah. Am I audible now?
Yes, ma'am, you're audible.
Yes, ma'am.
Yes, thank you. You can see the PowerPoint, right? Is it visible, the PPT?
Yes, ma'am.
Yes, ma'am.
Okay, thank you. So one sample test or Z test is over, and next T test or student test or independent sample T test, that is also over. And third one is paired sample T test or matched pair test, that is also over. I hope when to use Z test, when to use T test, when to use paired sample test is clear to you all. Am I right, or you want any explanations in this regard? How to differentiate?
Ma'am, independent and paired, we didn't hear it properly.
Independent, yes. Okay. So independent sample t-test means here we will be comparing boys and girls or male or female, English medium or Tamil medium. So these two subgroups are entirely different. So they are independent to each other, right? So it is called independent sample t-test. But under paired sample, if you take, we will be comparing the pre-test and post-test scores of the same student. Am I clear?
Got it, ma'am.
test. So for the same sample,
Ma'am, can you
we
please
compare the
define?
pre-test and post-test. So it is called paired sample or matched pair test or correlated t-test. Okay. Which one? The same concept? Okay. I'll explain the same thing again. So independent means we will be comparing the two subgroup. Gender can be classified into two subgroup, male and female. So if you're going to compare male and female, these two subgroups are independent to each other. No way male are connected to female. Sorry, yes, male are connected to female. So two groups are independent, two subgroups. So it is called independent sample t-test. But in experimental research, we will be comparing the pre-test and post-test scores of the same student. So it is called paired sample t-test or matched pair test, or we can do correlated t-test. I hope I clarified. Shall I proceed with the next one?
Yes, ma'am.
Okay. So one sample test or Z test, as I told, it is used when the population mean is known. So unless and otherwise your population mean is not known, we should not perform this one sample t-test. Okay. I already given one example for that also. And next one is paired sample t-test or correlated t-test or matched pair t-test. Okay. So it is used in experimental research. Okay. As I told, no. For experimental research, in order to compare the pre-test, post-test scores, we will be doing this paired sample t-test. So for this, we are comparing the dependent variable, that is the academic achievement scores before and after the treatment. Okay, so that is why it is called paired sample, before the treatment and after the treatment of the same students. So this is the layout. So O means we are giving, that is we are taking the scores of the students before the treatment, and here X is after treatment. So X is the treatment. Once the treatment was given to the students, we will be we will be conducting the achievement test and getting the scores of the students. So that is O. So OXO, that is before. This is before treatment, and this one is after treatment. And we will be we are going to compare the achievement scores of before and after treatment. So that is called paired sample t-test. Is it clear, this concept?
Yes, ma'am.
Yes, ma'am.
Yes, thank you. See, one-tailed, two-tailed, in the last class itself, I told, if the hypothesis is directional hypothesis, it is one-tailed. If it is non-directional, that is, if it is null hypothesis, then we'll go for two-tailed. So that is a different concept. Okay, it will take more time. Okay, I'll proceed with this. So this is paired sample t-test. And next we are moving to independent sample t-test or simply t-test. Or how to write the object. Yes, how to write objectives and hypothesis for paired sample t-test. You want me to explain this, otherwise I'll skip this and do the next one. Kindly text in the chat box. Yes, please. Let's skip this. Okay, so next one is so it is used to compare the mean scores of two subgroup. I told you already. So comparing the mean scores of two subgroup means male, female, boys, girls, Tamil medium, English medium. So we are going to compare the mean scores of two subgroup. And what are the assumption? As I told already, it should satisfy the condition normal distribution. Only the distribution is normal, we have to do the t-test. Otherwise, what is the equivalent? That is, if the distribution is normal, it comes under parametric test. If it is not normal, then it comes under non-parametric test. So what is the equivalent non-parametric test for test? Yes, can you?
Mann-Whitney.
Yes, Mann-Whitney U-test. Okay, so the equivalent non-parametric test for t-test is Mann-Whitney U-test. So I will be focusing only on the parametric test, so let it be. Okay. Next important thing, that is when doing the t-test, we must make sure one variable is continuous variable and another one is discrete variable. The continuous variable means it has to be interval or ratio scale. Discrete means it has to be a nominal scale. So here academic achievement is a continuous variable and gender is a discrete variable. Okay, so last class itself we discussed what is continuous and what is discrete, and also I have given many examples for continuous and discrete variable. So I don't think I need to explain even more on this. Okay, so these are the assumptions regarding t-test. So when we will be performing the t-test, when the demographic variable is classified into two subgroups, then we will be doing this t-test. Okay, for that we will be comparing the mean scores of boys and girls. Comparing the academic mean scores of boys and girls. So for that, we need to have the continuous variable and discrete variable, that is academic achievement and gender. Okay. Okay. So with that, let me move to the SPSS. Yes. So now I'm going to do t-test. Okay. So first we should go to analyze. Under analyze, we have to check compare means, because we are going to compare the mean scores of boys and girls. So, okay, let me do how to perform one sample t-test. So one sample t-test, you just click that. So here I have to shift the academic achievement to the test variable, and here test value, under the column test value, I have to give the population mean. Okay, I told no, here we will be comparing the sample mean with the population mean. Am I audible?
Voice is breaking, ma'am.
Comparing the population mean with the sample mean. So I have given the sample academic achievement. This is breaking. Is it clear now, or still it's breaking?
Yes.
Shall I proceed now?
Yes.
The voice is breaking.
So academic achievement is nothing but the sum. Oh, still it's breaking. Shall I proceed now? Yes, please. May I know? Shall I proceed?
Yes, ma'am.
Okay, thank you. So now for sample mean, I have shifted the academic achievement to the test variable, and I have to feed the population mean value, right? And it has to be feed here under test value. So let it be academic achievement, some average of okay, I'm going to give 50. Okay, so this is my population mean, and SPSS, it will calculate the sample mean with the help of the academic achievement scores. So I have to check the options. In the last, see, the confidence level is 95%. If the confidence level is 95%, what will be the significance value? Can I get the answer in the chat box? Yes.
0.05.
Jagannathan. Yes, 0.05 level of significance, or we can say 5% level of significance. Okay. So in SPSS, defaultly it was given as 95%. So let it be 95. Okay. So 95% confidence level means here the error will be 5%. That is, the significance level will be 5%. Okay. So continue and then okay. So here. Okay. So this is N, the number of students. Mean value is 76 and standard deviation is 12. And this is the one sample test result. So the T value is 43.020 and degrees of freedom. So this is what we want. The two-tail test significance value. So the P value is 0.000. So I just want to... Can you able to see the slide probability value?
Yes, ma'am.
Yes,
Thank
ma'am.
you. So here, see, if the p-value is less than 0.05, it is significant at 5% level of significance. Okay, it is significant at 5% level. And if the p is greater than 0.05, it is not significant at 5% level. If the p-value is less than 0.01, it is significant at 1% level. And if the p-value is greater than 0.05, not significant at 1% level. So this is the rule for writing whether the hypothesis is accepted or not, whether it is significant or not. We have to check the p-value. Because the error is 5%, right? So 5% means what? 5 by 100. So it is 0.05. So if the p-value is 0.05, it is greater. Yes, it is less than or equal to 0.05, it is significant. Or if it is greater than 0.05, it is not significant at 5% level. Similarly for 1% also. Okay, you have to be very thorough in this p-value. Only then we can check whether the hypothesis is accepted or not, whether it is significant at 5% or 1%. So once you know this, now let me go to the SPSS window. So analysis, compare means one sample t-test. Okay. So here comes the output. So now if you check the p-value, it is 0.000. So so from this value, we can infer that what it tells, whether it is significant or not significant.
Significant.
Yes? Significant at 5% level or at 1% level?
5% level.
Yeah, it is significant at 5% level, and also it is significant at 1% level because it is less than 0.01 because it is 000. So it is significant both at 1% level and 5% level. Can you able to understand?
But
Yes.
ma'am, when we actually worked with the statistics, we set that confidence level as 95%. Will that not make any difference when the statistics is running the program?
Actually, what we are doing is we are fixing that less than 5% will be coming. 95% only. It will not go more than 5% error. By default, we are fixing the error as 5%. So less than 5%, we can take 5% or 1%. Okay, it will not go beyond 5%. Yes?
Yes, ma'am. Yes, ma'am.
Okay.
Thank you.
Yes. Okay. So from the p-value, we can check whether it is significant at 5% level or it is significant at 1% level or it is not significant. If it is not significant at 5% level, obviously it will not significant at 1% level also. Okay. So this is the p-value here. With that p-value, we can check whether it is significant or not. So now here it is less than 0.01. So it is significant at 1% level of significance. So it shows that there is suppose if we frame the null hypothesis like that, that is, there is no significant difference in the population mean and the sample mean in terms of malnutrition or something like that. So now this null hypothesis is not accepted because the p-value is less than 0.01. So we should go for alternate hypothesis, which means there is significant difference between the population mean and the sample mean. So it shows that the students are by sure they are under nutritious or malnutritious. Okay. So this is how we have to interpret the result, whether there is significant difference between the population mean and sample mean. And now let me check the sample mean. Okay. Okay. Only the academic achievement. See, the academic achievement, what is the value of academic achievement? So here it is 76, right? So the mean value of academic, so we are not supposed to do this for academic achievement because we are checking the malnutrition. For that example I have given. So here the value of academic achievement for the sample mean is 76. And what is the population mean we have given?
50.
50. So which is greater, the population mean or sample mean?
Sample mean. Sample mean.
Sample mean. It shows that the sample mean is more than the population. So average academic achievement will be 50 only. But here the students' average score is 7. So some practices I've done so that most of the students have scored higher marks. So the mean value is more here. Okay, in such a way we can interpret. Okay, just for an example, I'm telling this. So here the sample mean is more than the population mean, because already we have given the population mean as 50, but the sample mean is 76, and also the significance, it is significant at 1% level. So the sample mean is more, population mean is less. Okay, this is how we have to interpret. So one sample Z test is over. Next I'm moving to T test. Okay, analysis, compare means. For T test, we have to check with independent sample T test. I already told, because in T test we are going to compare boys or girls. Boys, girls means both are independent, right? So we should check with independent sample T test. So here, so under test variable, I have to shift academic achievement. That is the continuous variable. I have to shift to the test variable. Under grouping variable, I am going to shift gender. Okay. So after shifting gender under grouping variable, I have to define the groups. So I have given 1 for male and 2 for female, right? So group 1 is 1, group 2 is 2. I have to assign values, continue. And if you check the options here, the 95%, it is by default, the error will be 5%. Okay, continue and then give OK. See? So here, this is the number of male and number of female. And this is the mean value of male and mean value of female, standard deviation of male and standard deviation of female. And here, we have the Levick's test of equality of variance. So here we can check the value. See, the significance is 0.9. And here you have test. See, we have two T values, minus 3.923 and minus 3.940. So now which value we have to check? So now see, this is the P value here. So the P value is less than 0.01. So still here also, it is significant at 1% level of significance. Since we have significance, the equal variance not assumed. So we have to go with the second T value, minus 3.490, because there is significant difference between boys and girls, because the P value is less than 0.01, which means significant at 1% level, right? See, let me go to the PPT so that. Suppose my objective is like this. Okay, I have to frame the objectives for independent sample T test like this, to compare the mean scores of boys and girls in their academic achievement. So this is my objective. What I'm going to do, I'm going to compare the mean scores of boys and girls. And the null hypothesis I have to frame like this. There is no significant difference in the mean scores of boys and girls in their academic achievement. So this is how I will be formulating my objectives and hypothesis. And I will be comparing the mean scores of boys and girls. There it was given as male and female. Okay, both. So boys and girls or male or female. So once we frame the objectives and hypothesis, we are supposed to now, the significance value, it is the P value is less than 0.01. So it is significant at 1% level of significance. So which means the null hypothesis accepted or not accepted, rejected?
Accepted, ma'am.
No, it is rejected. Okay, because there is significant difference between boys and girls, but we have formulated the null hypothesis as there is no significant difference between boys and girls. So we, in the null form, we have formulated the hypothesis, but the significance value tells that there is significance between boys and girls, because the P value is 0.00. So which is significant at significant, which means there is significant difference. It is not significant. It is significant at 1% level of significance. So, see, this will be the table. So here the mean scores of boys and girls in their academic achievement. Here we will be entering the mean value of boys, girls, standard deviation of boys and girls, and we have to enter the mean number of boys and girls. And here I will be entering the T value. So it was minus 3 point something. So even though the T value comes in minus, in negative, we have to enter in positive only, because if you look into if you check the formula of T value, it comes in model. So for modular, even the minus sign will be converted into plus. So even though it is in negative, we have to enter the data in plus for t-test. So it is 3 point something. And the p-value is what? Minus 0.00. So which is less than 0.01. So which means under remarks, we have to write significant. Significant means what? We will be rejecting the null hypothesis, which means there is significant difference. See, let me enter the values here so that yes. Check the application. Okay, so now I'm going to copy this table and the p-value is minus 3.9. Let me round to 2 decimal places. So 3.92 is the t value here. Okay. Is 3.92. Okay. So the mean of boys is 73. 73.80. And for girls, the mean value is 78.47. And the standard deviation is 12.25. And for girl, it is 11.42. And N is 212 for boys. And for girl, it is 188. And the p-value is 0.00. So it is the p-value is, it is less than 0.01. So which means it is significant. It is significant at 1% level. It is significant at 1%. Am I clear? Is it clear or not?
Yes, ma'am.
Yes. So, from the above table, it is observed that the mean scores of, see, if you check the mean score, whose mean score is higher, boys or girls?
Girls.
Girls, yes. So from the above table, it is observed that the mean scores of girls, that is 78.47, is higher than boys, that is 73.80. Okay, so from the above table, it is observed that the mean scores of girls is higher than boys. Since the p-value is lesser than 0.01, the null hypothesis is rejected at 5% level of significance. Okay. The p-value is less than 0.01. Yes. Since the p-value is less than 0.01, the null hypothesis is rejected. So what is our null hypothesis? There is no significant difference in the mean scores of boys and girls in their academic achievement. So this null hypothesis accepted means we should go with the alternate hypothesis. So hence, there is significant difference. Hence, there is, instead of there is no, we have to type there is significant difference in the mean scores of boys and girls in their academic achievement, etc. So this is how we have to write the inferences. Is it clear? Yes?
Yes, ma'am.
Yes. So the independent sample t-test is over. So what we did is, in the analysis, we just go to analyze, and under analyze, compare means, under compare means, we should go to independent sample t-test. There we have to shift the continuous variable to test variable and the demographic variable, that is the descriptive variable, gender to the grouping variable, and we have to assign the value 1 as 1, 2 as 2, and then we can do the, you have to click OK, then the output will be displayed. You want me to do it one more time, or is it clear?
Clear, ma'am.
Yes. Okay. So one sample t-test is over. Independent sample t-test is also over. Paired sample t-test. So for that, we need to have pre-test and post-test scores. Since I don't have that score, so let us, okay, let me create that. So pre-test. Okay, I should not give space, no. So, and then post-test. Okay. We are not supposed to do this. Okay, we should not manipulate the data, but still, now for the time being, I'm doing that. Okay, so let it be the pre-test and post-test scores of the students. So after conducting the experimental research, we will be getting the post-test. So after the treatment, before the treatment. So before the treatment, we will be conducting a test, and that is called pre-test. And after the treatment, we have to conduct an achievement test, that will be a post-test. Now we are going to compare the pre-test and post-test scores of the students. Since the same students test we are going to compare, it is called paired sample test. Okay, so for that, let me go to analyze, compare means, and then paired sample t-test. So here what I have to do, I have to shift the pre-test to variable 1 and post-test to variable 2. So we have shifted the pre-test and post-test scores and go to options. It is 95% by default. Continue. Okay. So this will be my output. Okay. See, this is paired sample. So the pre-test mean and the post-test mean, and this is the n value will be same only. This is my standard deviation value. And if you check the significant value, we have to check this value, significant two-tail. That is, now tell me here, the significant value is 0.526. So that is, it is nothing but the p value. The p value is 0.526. So now it is significant or not significant?
It's not significant, ma'am.
Yes, not significant, because the p value is it is greater than 0.05. It is very simple. See, if you multiply 0.526 into 100, what you will get? 0.526 into 100 will be, yes,
Point.
52.6.
52.6.
Mute yourself. 5 to 6 into 100. Okay. Can you able to see the calculator?
Yes, ma'am. Yes, ma'am.
Yes.
Yes, ma'am.
So 52.6. We fix the error. We fix the error to 5%. What is the error here? We fix it as 5% error. But here the error is 52%.
52%.
Okay. So P value is nothing but the probability value. But already we fix the error as 5%. But here the error is 52%. So it clearly shows that we have to accept the null hypothesis. Okay. There is no significant difference between the pre-test and the post-test scores of the students, which means the treatment what we have given is not effective. It is not effective, and hence the pre-test and post-test scores are almost the same, because we manipulated the data and we have fed it. So that we got not significant, I don't know. But once we give the treatment, definitely there will be a significant difference between the pre-test and post-test scores. Okay. So let me go to is it clear, or you want me to do it one more time? Paired
Clear,
sample
ma'am.
t-test? Yes.
Clear, ma'am.
So now let me go to the PPT. So here I have written the objective for paired sample t-test. Yes, here it is. So to compare the mean scores of pre-test and post-test in grammar before, after teaching through play method. So here the treatment is teaching the students grammar through playway method. So before teaching through playway method, I have conducted an achievement test for grammar, and I have taken the pre-test scores. And after teaching through playway method, I have conducted test, I have taken the scores, and that is my post-test scores. So now I'm going to compare the pre-test and post-test scores. Okay, so now the null hypothesis, there's no significant difference in the mean scores of pre-test and post-test in grammar before, after teaching through playway method. So now I have not given the table here. I'm very sorry for that. So what will be, how we will be interpreting the table here? So analyze, compare means paired sample t-test. Okay. Okay. So now in the mean column, we are supposed to write 79 and 80. Right. N value is 24, and standard deviation is 7.7, 9.9. And the T value is 6 point. Though it is a negative, we have to write in positive. So 0.643, and the P value is 0.526. So since the P value is greater than 0.05, the null hypothesis is accepted. Hence, there is no significant difference between the pre-test and post-test scores of students. Is that clear?
Yes, ma'am.
Yes. So in today's session, due to network issues, I'm not able to start at correct time. I'm very sorry for that. But in today's class, we discussed about how to enter the data in SPSS, or we can enter the data in Excel. Later, we can import the Excel data into SPSS. So two ways we can do. So which one is convenient for you, you can go with that. Okay. And then what else we have discussed? We discussed about the descriptive statistics, how to do the statistics like central tendency and measures of dispersion, skewness, kurtosis, those things we have discussed in today's class. And also we discussed about the different types of t-test, right? The different types of t-test, that is one sample t-test, independent sample t-test, and the sample t-test, one way anomalous F-test, we'll discuss in the next class. So is it clear? And if you have any queries, we'll discuss that now.
Thank you, ma'am.
Thank you so much,
Dear
ma'am.
participants, dear participants, is there any query? Please put it in chat box.
Yeah, I do have a query. I'll put it in the chat box.
Yeah.
Yes. So when to use equal variance assumed and when to use equal variance not assumed. See, one more thing, once I just forgot to say this. Once you feed the data, everything, I have assigned the values, what is male, female. Once you did this, you have to save this file. Otherwise, without saving the file, if you close it, for the next time, if you're going to open, next time you have to assign the value one more time. So once you did everything, you just save as master table, SPSS master table. Okay. So that it will be easy for you to do the analysis whenever you want. Okay. See here. Oh, I have not shared my screen, right? Is it visible now?
Yes, ma'am.
So now that it is the p-value, from the p-value we came to know there is a significant difference between boys and girls. So equal variance not assumed. Okay, you have to check the t-value, equal variance not assumed. Suppose if there is, if the p-value is more than 0.05, which means there is no significant difference. So equal variance assumed. So accordingly, you have to check the values. Okay. But usually, it will not make much difference. If you take this value, it will not make much difference. You can go with any other value. Okay, that will not going to affect your analysis part. So it is not a big deal. Okay.
Thank you, ma'am.
अभी तो नहीं होगा.
See, once you download the trial version, you can do the analysis only for 30 days. After 30 days, you can't use the same, even though you will be doing the analysis, you will be downloading the software in a different device, but still the mail ID will be same, no? So you can't download it again. Okay, so you make sure once you download, it will be available only for 30 days. So make use of it productively.
Ma'am, so should I buy a version to use it for long?
Yes.
Or is it a fee?
Yeah, it is not advisable to use pirated version, but it is very costly for us to afford. So most of the students, they will be using the cracked version only. Okay, but
Where should I download it?
It is no, the cracked version. I have no idea, because being in this profession, I can't say that you should use the cracked version.
Understood.
We have to, yeah. So it is up to you. Okay.
Okay, ma'am. Thank you.
Okay, ma'am. Thank you for your grateful session, ma'am. Even though we had a technical glitch, as usual, we had a wonderful session and you have cleared all our doubts, ma'am. Now I request Ms. Sabita to propose a vote of thanks.
Good afternoon to one and all present here. Thankfulness is the natural impulse to express the feeling. So on behalf of Faculty of Education, Dr. MGR Educational and Research Institute, I would like to extend my gratitude to our resource person, Dr. A. Shyamala Devi, for sparing her valuable time to share her insights on the second day workshop on SPSS. Really, the session was very useful for the budding and blooming researchers. Even though there's a lot of technical issues at the beginning, you really overtook it and made it an enjoyable learning, ma'am. Thank you so much, ma'am. We had a clear idea on what is SPSS, how to create it in Excel, and how to change Excel to SPSS, and a lot more with examples, ma'am. Thank you so much. It's a great honor to thank all the participants of this session. We would like to extend our gratitude to our Honorable President for granting us permission to organize this workshop. Please join with us tomorrow at 2 p.m. for the third day workshop, and we won't be providing the feedback form for today's session. Thank you all.
Okay, thank you, as well as sorry for the inconvenience at the beginning of my session. Thank you.
It's okay, ma'am. It's okay. Nice. But we had a wonderful session. We want to hear you from you. That's it.
The time was very tensed in between the presentation.
Yeah, I understood, ma'am.
Yeah.
Because practically, if you are taking SPSS, this we have to face it. So it's okay,
Yeah,
ma'am.
today I'm using a different device. So right from the beginning,
Ah.
I downloaded Zoom and everything. Asked for
Yes,
uploading and so many things. It took a lot of time.
I understood, ma'am. Anyway, ma'am, you have done it.
Thank you, ma'am. Thank you.
Yes, ma'am. Yes, ma'am. Thank you so much, ma'am. Thank you.